All right, this is 8.1, oblique triangles, the sine law. So the difference between SOHCAHTOA and what we're going to learn today is that the triangles are not right angles. Okay, that's it. If you have a right angle, you can't use SOHCAHTOA. Okay, that should be obvious from the hypotenuse that's needed in sine and cosine, but even the tangent law in TOA, tangent is opposite over adjacent, you cannot use unless you have hypotenuse. You don't have opposite or adjacent or hypotenuse unless it's a right angle triangle. Okay, so we're going to deal now today with non-right angle triangles, okay, where we still know things about the triangle, but we just don't know, or we don't have that it's a right angle. Okay, so oblique triangles is any triangle that is not a right triangle. So that's what we're dealing with, oblique triangles. So acute triangles are all three angles of the triangle are less than 90 degrees. So an acute triangle looks something like this, where each of the angles, they're all less than 90 degrees. And an obtuse triangle, one of the three angles is greater than 90 degrees. So a triangle like this, okay, where this angle here is greater than 90. Okay, I drew that actually pretty close to 90. I can draw it more exaggerated like this. Okay, this angle here is greater than 90. And this is all less than 90 degrees. Okay, so that's the difference between acute and obtuse. They're both oblique triangles. Neither has a 90 degree. Oblique has all less than 90. Obtuse has one that is greater than 90. Solving oblique triangles. To solve an oblique triangle, you need to know the measure of at least one side and any two other parts of the triangle. So we need three pieces of information, including a side. Okay, so we could have all three sides. That would help us solve it. Or we could have one side and two angles. We have two angles, we have all three angles, right? The trigonometry of oblique triangles is not as simple of that of right triangles, but there are two theorems of geometry that will help be useful. So sine law, which is 8.1, and cosine law, which is 8.2. 8.3 and 8.4, these are just solving problems. With sine and cosine law. That's all it is. Solving word problems, let's say. That's what it is. We're done. So this year we apply sine law and cosine law only to acute angles. To solve right angles using techniques we learned in Unit 7 is often simpler and faster. And what are those techniques? What do we call them? Yeah. SOHCAHTOA, right. Okay? All right, here we go. The sine law states that its sides and angles are related in this way. Sine of the angle A, that's the vertices A, over the side length, little a. Remember I told you about this nomenclature? The vertices is the capital, the side length is the lowercase. So that ratio is equal to the ratio of the other vertices, sine B, over its side length B. Okay? And, you know, we can rearrange this or we can rewrite it with the side length on top, right? You guys understand how this works, right? We're just inverting them, right? The equality stays the same. It's just like cross multiplying. If we cross multiply this, we'll get the A and B on top. Okay? So these two expressions are equivalent, and that's it. That's the sine law, using these expressions. So you can imagine now how these problems are going to play out if we have two sides and two angles here. Sorry, one side and two angles, right? We only need one of these equalities to solve, right? If we have angle A, angle B, and side B, we can solve for side A. Or if we have angle B, side B, and side A, we can solve for angle A, right? We just need three of these variables. We can solve for the fourth unknown. That's how it works. So it says, to use the sine law to solve problems, you must either know lengths of two side lengths and one non-contained angle, So we call this SSA. Why do we call it SSA? Because the sides are next to each other, side, side, angle. Okay? Or two angles and the length of any one side. So what does that mean? Angle, side, angle. Right? And now we have two angles. We actually have three. Right? You could even say AAAS. These are the same thing, right? Because if you have two angles, you have all three angles because we know all three have to add up to 180. But it's easier to think of it as just two. Angle, side, angle. So any one side and two angles, we're good to go. Okay, why is this important? Because this is going to allow us to determine whether or not we use sine law or cosine law, which we're going to learn later in this lesson. Cosine law being harder. I don't want to say harder, but it is harder. It's harder. And the way, you're going to find out in 8.2, but the way we use, when we use cosine law is when we have side, angle, side. Okay, that is cosine law. But we'll get to that in a minute. Sine law is the easier one. So if you have two angles in a side, or you have two sides that are next to each other in an angle, we're good to go. Okay? Once you have set up the sine law with the given information, you solve the unknown side length and angle measure by cross-multiplying the equivalent fractions and then isolating the missing quantity. It's pretty easy. When finding a missing angle, you must use the sine -1, which we've learned already from chapter 7 on your calculator. To solve a triangle means to find all the missing side lengths and angle measures. We've learned this as well in chapter 7. Okay? Let's do some examples. Finding the length of a side using the sine law. So find the length of the indicated side, N and C, to 1 decimal place. So this side and this side here to 1 decimal place. Okay? Now, it's important to understand what information is being given here. So who can tell me what information in terms of sides and angles? Rudy?
There's a length of the side and two angles.
Yes. So we have side, angle.
Isn't that angle?
Yeah, you're right. Angle, angle, side. Or you could say angle, side. No, that's for, no. We'll leave it at that. Angle, angle, side. Okay, so angle, angle, side, we can figure out this side or this angle, but I don't think we need it, right? We just need the ratio now of one of the angles over its side length and equate it to the other angle over its side length. And now, remember, we can pick which formula we use. We can either use this formula or this formula. Both will give you the same answer, but depending on what you're looking for, one of them is going to be less steps. One of them will be easier to solve, okay? So which one do you think I want to use? This one or this one? Jafet is going to decide here. This one or this one? For this problem, we're looking for n. We're looking for a side length. So what do you think, Jafet?
The second one.
Which one?
The second one.
Yeah, the second one. Why'd you pick that?
Because it's the numerator.
Yes. He picked the second one exactly because the n is already on the numerator. We know we want it on the numerator because we want to solve for it. If we use this one, we're going to have to do some cross multiplying to bring it up and move things around. We're going to use this one. So side length over the sine of the angle. Okay, so here, how do we do that? Okay, we're going to say here that the side length n, and we'll put it on the left so it's perfect, over sine of the angle n is equal to, now we're going to choose the other side that we have information about. I'm not going to choose L because I don't know the angle L. I mean, I could calculate it, but I already have angle M. So I'm going to say M over sine M. Okay, now that's the formula. And lucky enough, we have three pieces of information. We have angle N, we have side length M, and we have angle M. So I can just sub those in. N is my unknown. Sine 41 equals to 4.5 over sine 57. Okay? Any questions up to there? Now, all we have to do to get n by itself, we need to multiply both sides by sine 41. These cross out, so I'm just multiplying this by sine 41. Okay, now I would advise all of you to try this on your calculator, because you got to get comfortable doing this. You can do this in one step, actually. Like, you don't need any brackets, you just do 4.5 times sine 41 divided by sine 57. All of that should give you 3.5. And it says to one decimal, so I'm going to get rid of the 2. 3.5 centimeters. You did not get that on your calculator, something is wrong. You might be in radians. You need to verify that you can do that. You get what?
Wait, under 4.5.
Yeah, sine 57.
And I should get, oh,
You have to multiply it by sine 41.
I'll multiply everything?
Yeah, see? Over here. Because I had to get rid of this on the denominator. Everyone's good? RC, take your bag down, please. Are you in radians? Does it say RAD or degrees at the top? D, okay. So you're gonna, just like this, Junior, watch my calculator, okay? You're gonna write 4.5 times sine. Now the only one that might have trouble with this is RC, because he can't write sine 41. He's gotta write 41 then sine. Divided by sine 57. That's it. 3.5. Everyone good? All right. You got it? Okay. Here we go. We want to get C. Now I'm going to skip a couple steps. I'm not going to write in the actual variables. I'm just going to go right to the answer. We want C, so I'm going to put C over sine 40 is equal to two pieces of information that I have already. The side length is first, 32 over sine 60. Okay, so C is going to be equal to this, everything multiplied by sine 40, 32 times sine 40 divided by sine 60, right? 32 times sine 40 divided by sine 60. 23.7 or 0.8. Yeah, 8. Okay? Centimeters. And you can look at the triangle. Does that make sense? Okay, yes it does. It's less than this. Does the 3.5 make sense? Yeah, it does. That's a good way to check. Next, finding an angle using the sine law. Find the measure of the indicated angle. Now we're working on angles, so the same thing. And this time I'm going to use the formula where the angle is on top. So I'm going to say sine theta, and I'll keep it on my left, is over 5.5 is equal to sine 65 over 6.1. And now I can just multiply both sides by 5.5 and I'll get sine theta. So sine 65 times 5.5 divided by 6.1. So I get 0.81716. Now it's good to hold as many of these decimals as you can. Just multiplying by 5.5. Sine 65 times 5.5 divided by 6.1, right? Now what I'm going to do is the sine inverse, right? Theta is equal to sine inverse of this. Theta is equal to 54 point. Looks like the degrees are to whole numbers, so I'll just say 55. It's 54.8, but I'm going to round it to 55. Okay? Any questions? Next one. Easy. This is easy, right? Maybe it's even easier than SOHCAHTOA. I don't know. It's a competition. Which one's easier? Theta is over here. So I'm going to say sine theta over 15 is equal to, now I'm going to use these sides, sine 80 over 17. Theta is equal to Okay, I'm going to show you a little trick on your calculator. 6.33, we'll just say 60. Okay. There's a little more advanced trick, but if you figure this out, you're going to want to use this in grade 11 and grade 12 for sure. Things are going to get complicated and messy. You got to kind of keep track of this. But watch what you can do here, okay? So I have sine 80 times 15 divided by 17, right? So I'm going to go sine 80 times 15 divided by 17, okay? There's my 0.86. Can you guys see that?
Yeah.
Right? Now, I have all those decimals. That's my sine value. Now, what I want to do with that is I want to do sine inverse of this value, right? But I don't want to type all that out again. Here's what you can do, okay? And I'm positive all of you guys have this feature on your calculator. Okay, here's what you can do. I want to sine inverse this. You guys got that, right? You understand what I'm doing? I see you listening. If you press second, at least on most of our calculators, if you press second function, sine inverse, okay? Sine inverse, that number's gone. I have to type it all out again. I can just use answer, because that was my previous answer. Now most of you will have answer as a button. It could be either like a straight button or a second function button, but that answer will store that last big number, and then just press equals, and that's it. Okay? What?
You have to press
Oh yeah, you gotta press this button, second function.
and then press sine again.
See, it's up there in like a different color. Do you see it, Jaden?
Yeah.
You gotta get that button, so you press second function and then this button. Okay? How do you go back to the other value? You press answer. I'll just show you like a real simple example of how answer works. Say we do 16 times 4, okay? With 64, right? Now I want to I don't know. I want to multiply 64 or add 17 to 64. Instead of rewriting 64, what you can do is just put answer plus 17. And it'll add the previous answer, which was 64, to 17. Okay? All right, we keep going here. 3. Solve the following triangles. Super easy, super easy. We want to solve the whole thing. So we need to get this side, which is A. We need to get this side, which is B. And we need to get this angle. We can get this angle right away. Let's do that. So we're going to do 180 minus 81 minus 59. We know this is 40. Okay? So we already got that. Now we need our two side lengths. We'll start with A. So we'll say A over sine 81 is equal to, we need side length that we have both values. So I gotta use C. So I'm gonna say 25 over sine 40. So A is equal to, multiply this by sine 81, so that cancels out, right? So I'm gonna do 25 times sine 81 divided by sine 40. Okay, that's the answer. 38.4 millimeters. Okay, now we'll get B. We'll say B over sine 59 is equal, I can use the same ratio, 25 over sine 40. B is equal to 25 times sine 59 divided by sine 40. 33.3 millimeters. Any questions? Okay, next one. Here we have a bunch of information. First I'll get the angle. So 180 minus 62 minus 43, 75. Okay, Now I have 3 angles and a side. Here's my ratio that I'm going to use to solve for C and A. Let's start with A. A over sine 75 is equal to 70 over sine 62. A is equal to 70 times sine 75. 76.6. Now we're going to find C over sine 43 is equal to 70 over sine 62. Any questions? Super easy. Triangle GHI, where angle H is 47. H and I. So the first angle we want to draw is 47. It's very close to 45 degrees. So I know 45 looks like that. So there's my angle H. It's 47. And then it says H, so that's opposite this angle, is 4.6. H, G, H, I. And it says I is 4. Okay, I clearly drew this triangle wrong because I have the 4 looking bigger than the 46, so I can adjust that. Right, because we don't know the other angles, so I was just guessing, but now that looks a little better, right? Keeping that 40-degree angle still the same. That's it. That's enough information. We have 2 sides and an angle. We should be good to go. Let's go for, what side do we want to do with first? Let's go with I, because we have, let's go with I, because we have 1 piece of information. G, we don't have any information. We don't have the angle, and we don't have the side. So we have to work with I and H. H, we have both pieces of information, okay? So we're going for angle I. So I'll put it on top. Sine I, which we don't know, over 4 is equal to sine 47 over 4.6. Okay? Now we can say sine I is equal to this. So sine 47 times 4 divided by 4.6. Okay, 0.63595974. Now, I want that whole value. I want it in my calculator. I don't want to have to retype it. I'm just going to say angle I is equal to, I'm going to say sine inverse, answer, 39.5 degrees. Good to go. Oh. Not done. Damn. Thought we were done. Okay, couple word problems. 2 scuba divers are 20 meters apart below the surface of the water. Okay, so let's do our little drawing. Here's our water surface. Here's our scuba diver. Clearly, I did not take art class. Here's our other scuba diver swimming along. That's a snorkel, but whatever. We'll pretend, or I'll draw a scuba pack, the air container, right? There we go. Okay, there's our scuba divers. Okay, they're 20 meters apart below the surface of the water. So from here to here, that's 20 meters. They both spot a shark that is below them. All right. The angle of depression from diver 1 to the shark is 47, and the angle of depression from diver 2 is 40. So it's sharper for this guy. So the shark is going to be closer to him. So let's put our shark here. Oh boy, this is going to be rough. I can't draw a shark. I don't even know what a shark looks like. I don't know. There's my shark, okay? It's not bad. It's not bad. All right. So the angle of depression from diver 1 to the shark is 47. So he's too close to him, but let's put it over here. Let's see. There. That's all pretty 47. So remember, angle of depression is from the horizontal. So there's 47. Okay? The angle of depression from diver 2 to the shark is 40. So this angle here is 40. Not bad. That's pretty much a 40 angle. I think I drew it okay. Okay, how far are each of the divers from the shark? Okay, so we want to know this value. So let's do A, B, and C. We want to know. This is B. This is A. We want to know the distance from the shark. So this guy and this guy. Right? We want to know B and A. And we have 20, right? This is our 20 meter up here. Okay? So, how can we solve this? Who's got an idea? Yeah, Maxis.
I guess first you find the angle of C.
Yeah, you can do that. This angle?
Yeah.
I don't know if we need it, per se. Yeah, we do, actually. We do. You're right, because it's opposite 20. Okay, so what's that angle? Do 180 minus 47 minus 40, 93. That looks pretty close to a 93 angle. I'm pretty happy with my drawing. Okay, 93. Now what do I do, Maxis? Now it's super easy, right? It's just like one of these triangles. So what do I do? I'm going to put the unknown on top. So which one do you want to go for, B or A?
I'd probably go for A.
Okay, so we'll put A over what?
47.
47 or sine 47?
Sine 47.
Right? Is equal to?
Yeah, how do I find that? I don't know the number up top.
You need to use something where you have both the side and the angle. Right? I have it written here. You're going to use C, right? So what is it? What's the length? Maxis, these two pieces of information you need to use here. So what's the side length?
Alright, I'll go.
You don't know, you have no clue what this distance is? It's given in the problem and it's written right here.
That's 20.
Right, 20 over the opposite angle, sine what?
I keep on getting math error online, so I think I'm doing it wrong.
I'm just asking you for the angle right now. We're still not even solving it.
93.
Yes, 93, good. Okay, now we can solve. A is just equal to 20 times sine 47 divided by sine 93. That's it. So do on your calculator, 20 times sine 47 divided by sine 93. 14.6. And that's in meters. Okay, does that seem reasonable for this, the way I've drawn it? For this length? Yeah, it seems reasonable. Beautiful. So now we're going to go for B. Andrew, solve for B.
So we're going to go B sine 40.
Yep.
40 over 20 sine 93.
Yep. B is going to be equal to 20 times sine 40 divided by sine 93. 12.9 meters. 12.9. Seem reasonable? Yes, it does. Beautiful. Okay. How far are each of the divers from the shark? Diver 1 is 12.9 meters, and diver 2 is 14.6 meters from the shark. From imminent. Oh my god, I can't spell imminent. How do you spell imminent? Anybody who's good at who's good at English here? Imminent. I'm gonna guess. I'm gonna scribble it. Imminent death. Yeah, it's like that. Imminent death. You guys know what imminent means, right? Soon. Yeah, like that. I-M-M-I-N-T at the end. Death. All right. Any questions with example 4? We can do this. We can do 8.2. We got this. Example 5. At noon, 2 tracking stations on Earth, A and B, 20 kilometers apart, measure the angles of elevation of a rocket that was launched with a weather satellite. Ooh, interesting. From station A, the angle of elevation is 41, and from station B is 75. Okay, so you gotta know, you gotta have an idea of what a 41-degree angle is and what a 75-degree angle is, right? Everyone should know that. Like, you gotta conceptually know, right? We know 90 is straight up, right? We know 45 is right in the middle of 90, right? Like, if you want a ball to go as far as you can, you throw it at 45, right? Like, exactly like that, right? So, based on that information, we should roughly be able to get these angles, okay? So from station A, the angle of elevation is 41. So this is going to be station A. Call that A, right? Angle of elevation is from the horizontal. That's always what you got to say in your head whenever they're talking about these angles of elevation or depression. They're from the horizontal. I always say that. So it's 41. So it's not quite 45. It's 41. It looks like that. Okay, this angle here is 41 degrees. 41. Okay? And from station B, it's 75. So station B, we know is going to be closer. We know it's not quite 90, but it's like, it's pretty steep, right? So it's going to be like this. This is going to be station B. There's my 75. Now, if you have a protractor, you can measure these exactly, right? That little protractor set, that's perfectly allowed. You could do this even better. You don't need to, right? Because we're going to use algebra. We're not using the protractor to solve it. But find the altitude, the height of the rocket to the nearest tenth. So we're going to connect these 2 stations, obviously, because we want to work with a triangle here, right? And the rocket is actually here, right? Here's the rocket. There's my rocket. Okay, we'll call this point C. Okay? It says find the altitude, the height of the rocket to the nearest tenth. So it wants to know this value, actually, 90 degrees straight down. It wants to know that. So we have our first word problem here that is combining non-right angle triangle with a right angle triangle. You're going to see this all the time in the next sections, 8.3 and 8.4. But you can see here there's kind of 2 triangles going on, right? There's this triangle here that's a 90 because we want the height of the rocket. We have this other triangle that's a 90. And then we have this big scaling triangle here that is a non-right angle triangle. Now we know that we're in the sine law section. So we probably want to use sine law, right? To figure out some stuff before we try to use SOHCAHTOA, right? We actually don't have any. Oh, we do have 20 kilometers apart. Okay, so this distance from here to here is 20. Okay, we know that's 20. Okay, and this 75 is that angle. Okay, so we can get